All right, this is part 4 of the Unit 7 test review. All right, so let's keep looking at these restrictions. So tangent. Tangent is a backwards C. That means we're going positive and negative. So where on the unit circle is the square root of 3? So let's go look at the unit circle at the square root of 3, a tangent. Okay, here it is at pi over 3. So we're going to go back, and we know this is pi over 3. It is in, if we look at the bottom here, it's negative square root of 3, so that doesn't count in quadrant 4. So there's our answer. Okay? All right, cosine again. Let's look at this one. Cosine means quadrant 1 and 2. So where is it square root of 3 over 2 is positive? Let's look at the unit circle. Square, it's cosine, so cosine is pi over 6. If we look over here, cosine is negative. It's not that. Cosine is positive, so it's square root of 3 over 2, which is pi over 6. So let me go back here, and the answer to this is pi over 6. All right, I'll do a couple more of these. Let's look at sine again. We know the sine is quadrant 1 and 4. Where is sine positive 1/2? So let's go to our unit circle. Sine is positive 1/2 at pi over 6. Let's go down here, and we see it's negative 1/2. So the answer to this one is also pi over 6. All right, let me get down here and click this back. So we know this is also pi over 6. All right, one more. Tangent. Where is the tangent positive 1? We know it's a backwards C, so it's quadrant 1 or quadrant 4. So unit circle. I know it's right here, which is in quadrant 1. That works. And if I go down here, it's negative 1. So this does not work. I'm trying to find my pen. There it is, right here. That does not work. So we're going to go back up here to quadrant 1, where the tangent is 1. And we look, and the answer is pi over 4. And that's perfect because it fits right into quadrant 1. So this is pi over 4. So remember, as you're doing these, if they are not in the right quadrants, then we say D and E does not exist. But we need to first check and make sure they are in the proper quadrants. All right, I'm going to move on to solving. Solving trig equations. Well, remember when you're solving trig equations that you are solving for the angle, and an angle has to be in the restriction I give you. And I'm going to tell you I want it in degrees. Okay? So degrees need to be what our calculator is set on. And I'll try to remind you when it needs to be degrees and when it needs to be radians. So I'm going to draw my box or highlight my trig ratio. And then I'm going to move everything else around it. So I'm going to subtract 5 first because that's what you do in algebra. You add and subtract first. So I get 4 sine of theta equals negative 2. So I'm still trying to isolate that. So I'm going to divide by 4. And I get sine of theta equals, put that in my calculator, it gets negative 1/2. Now, once I've isolated this and I have a number, I'm going to do the inverse. So the inverse, and then I'm going to switch these two. So the inverse of negative 1/2 equals my angle. That is what I'm trying to find. Now, in words, this in words means what angle has a sine of negative 1/2. So let me go to my unit circle. We use our unit circle a lot. where in my unit circle does sine negative 1/2? Well, here it is at 2 pi over 3, but we're doing degrees, so 120 degrees. Let's see where else. Sine is also negative 1/2 at 210. So now we have 120 and 210. Okay. Sine is, something looks weird. Nope. Sine is also negative 1/2 at 330 degrees. Okay. At 330 degrees. Let me make sure. Did I do this right? Nope, I did not. 120, that's cosine at negative 1/2. So our two that we need are 210, 210, and 330. So let me go back here. So I know I have 210 and 330. Now, here is my restriction. My answers have to be between 0 and 360, and both of these are, so both of these are good. Okay? All right, let's move on to the next one. Now look, this restriction is in radians, so my answer has to be in radians. Now, when you see negative pi over 2 to pi over 2, that is these two quadrants. Okay, quadrant 1 and quadrant 4 has to be these two quadrants. Okay, all right, but remember, one's going up positive, the other one's going negative. So let's first solve this. So I'm going to draw a box around tangent, so that means I'm going to subtract 1. So I get tangent of theta equals negative 1. Now I'm going to do the reverse. Sorry, the inverse. So I get tangent of negative 1, switch these two, negative 1, equals my angle. So what angle has a tangent of negative 1? I don't know. Let's go look. So it has to be in quadrant 1 and 4. Okay? So negative 1 looks like it's right here at 7 pi over 4. But let's go back for a minute and talk about this. So when I do this, tangent is just this part. Just this part, okay? So 7 pi over 4 is here. But 7 pi over 4 meant that I went all the way around my circle. Can't have that, okay? So this is 7 pi over 4 is really negative pi over 4. That is my answer, not this. Okay? Negative pi over 4 works. All right, let's see if we can try another one. All right, let's try another one. I know we got a lot of stuff that we're doing here, but I want to make sure you guys understand this. All right, solve the equation for theta. Now, it's in degrees here. Okay, we're talking about degrees here, so we're going to keep it in degrees. So I'm going to draw my box. I'm going to subtract 2. I get the sine of theta equals 1. Inverse. Inverse, switch these two of 1 equals my angle. I'm trying to find my angle. So what angle has a sine of 1? Okay, so we're going to go back to our unit circle and we're going to look. But look, my restriction is only between 0 and 180. But let's go look and see what we can find. So in my unit circle, let's look for a sine of 1. So we have 90 degrees, because up here, there's sine of 1. Do we have any other sines of 1? Nope, that's negative 1. So it looks like just 90 degrees. Now, when I put 90 degrees here, does that fall in my restriction? Yes, it does. So that is my angle. All right, I'm going to skip down and I'm going to try this one. So I notice I have cosine on both sides. I can't have that. So I need to keep the bigger one because I want to keep it positive, and I'm going to subtract this one from both sides. So I know 2 minus 1 gives me 1. I'm going to draw my line. Plus 1 equals, now 1 minus 1 is 0. Now I can draw my box around it because it's by itself. Subtract 1 from both sides, and I have the cosine of theta equals negative 1. Now it's inverse time. The cosine of negative 1, inverse cosine of negative 1 equals my angle. Now, my restriction's in radians. That means my answer has to be in radians. So let's look at this though. If I was looking at my coordinate plane, it looks like every quadrant is in it, because this is 3 pi over 2, except the fourth quadrant. Fourth quadrant doesn't count. But let's go see on the unit circle what angle has a cosine of negative 1. So we're going to our unit circle, and it looks like, let's go up top, not up top, it's 0. It's negative 1 over here at pi. It's positive 1 at 0 or 2 pi. Let me move this. I don't know if that will move. And it looks like that is the only, there we go, and it's 0 here. So let me go back, and I know this is at pi. And pi fits perfectly in my restrictions, so that is the angle. Okay? All right, topic 6, finding angle measures not on the unit circle. All right, so we're getting to this. So what I'm going to do is I'm going to stop this one and go on to the next part.